Yada Sirasa Devam Gauriputram Vinayakam Bhaktavasham Smara Nityam Ayukamarta Siddhaye Om Graha Pataye Namaha. Salutations to Lord Ganesh, the presiding deity of all the planets. So I mentioned before in my previous videos that we evoke the blessings of Lord Ganesh on any new undertaking. This is a new video. We'll ask Lord Ganesh to please bless us so that we may understand this presentation. Welcome back. This is part 3 of Astronomy, Astrology, and Time. In the previous video, we went through a few things. I have one of the slides up right now. We talked about the classical zodiac. This is a two-dimensional model of the zodiac here. All 12 signs plus the 13th sign, Ophiuchus. My conclusion is that is not to be considered a sign of the zodiac. Signs of the zodiac are 12 even signs. I think adding a 13th sign into the mix only confuses the issue. For all you astrologers that use Ophiuchus as part of your bag of tricks, good luck with that. And then we talked about the zodiac itself and a little bit of a three-dimensional model here. How the Earth, being on the other side of the sun, points to a specific constellation that is the sign of the month. So in this case, we see the Earth here, the sun pointing to Leo. So that would mean that the sun is in Leo in relation to the Earth. So the Earth is not in Aquarius, the sun is in Leo. So when the sun is in this part of the heavens, it would be crossing the constellation of Leo. So we gave a few more examples in the previous video. We also talked about a sky map showing the ecliptic path being this yellow marker here, yellow pointer, all the way over to this other one on the right side. That is the ecliptic, and that's where the zodiac constellations reside on the ecliptic. And we also notice the equator down here. This is actually the celestial equator. That celestial equator lines up with the equator of the Earth. So we need to know the difference between the ecliptic and the equator. They're usually different. They are different in space at this point in time, about 2,500 years ago, and we'll get into this a little further within this video or the next. The equator and the ecliptic were lined up. So that has a lot of significance, and we'll talk about that a little later. And we also talked about the path the sun takes as it moves through the heavens, this little palm tree being the Earth, how the sun rises from the east to the west and sets in the west, sunset here. So we have at sunrise through sunset, the sun will be taking a path through the ecliptic. But is the sun actually rising or setting? No. It is only the Earth that is spinning on its axis that causes the illusion that the sun is rising in the east and setting in the west. It's actually the Earth turning into the east that gives that illusion of the sun rising. The sun seems to be rising in the sky, but it's actually not. It's just the Earth moving that creates that illusion. That's why I call it the apparent path of the sun. It's not really the path of the sun. So we keep that in mind. That's a tropical situation. Western astrologers take that into serious consideration as the sun rises and the sun sets, and as the sun seems to move through the constellations, because every day not only is the Earth spinning on its axis, the Earth is also revolving around the sun. So it's moving. Takes approximately 30 days for it to move through 1 month or one sign. So we talked about that in the previous slide. Everyone should know from their elementary school or middle school geography courses that the Earth has a line going through the center of it, and that line is known as the equator. And it's this line right here, if I can draw it straight enough. So that line is known as the equator. Any countries that are south of the equator or in the southern hemisphere, any countries that are located north of the equator are in the northern hemisphere, for example. And I mentioned before, and I think I made a mistake on this, that the equator ran through Central America. Actually, it runs through South America. That's where we get our country known as Ecuador. So the equatorial line runs through South America. It split the Earth into two sections. Equatorial plane is a latitudinal line, and we have the longitudinal lines that run from north to south. And that will come into play when we discuss the different types of charts and the sections of the world. You can see these sections are different sizes. So in any case, we'll talk about that as we go along in our studies. But for now, remember that the equatorial plane, which runs out into space, we could say that if we extend this line, it will run out into space that way, and it actually comes around the Earth on the other side and actually runs out into space also. So that is a fixed line on the Earth known as the equator, and in space it's known as the celestial equator. And that's very important to note. If you look here, we see the equator down here. That line is the line that lines up with the equator of the Earth. This is actually the celestial equator. This equatorial line lines up with the equator on the Earth, whereas the ecliptic is different. The ecliptic, where the constellations of the zodiac reside, where the yellow pointers are, that is a lot different. There is a difference between those two lines, which comes to approximately, and it depends on the scientist, how they've calculated it, about 23 to 24 degrees. If we take a measurement from the ecliptic to the celestial equator, same on this side, from the ecliptic to the celestial equator, we'll come up with about 23 to 24 degrees of arc. Arc meaning a circle. This particular measurement here would be approximately 24 degrees at this point. And that's the difference between the actual ecliptical plane, where the zodiac resides, and the equatorial plane, where we would see the equator on Earth line up. We'll get into that further to make it a little more clear. Let's move on. Everyone knows from their geography lessons that the Earth is spinning on its axis. Axis north, axis south. These are imaginary lines. There's no line running through Earth. It's just an imaginary line, so you can get an idea that the Earth is spinning on that particular line or axis point from north to south. So the Earth is spinning. One revolution of the Earth takes approximately 24 hours. That's not exact, but we've learned in school that it takes 24 hours for the Earth to spin once on its axis. It's spinning from west to east. So here's west on this side. Here's west to east. How the Earth is spinning from west to east, it appears as if the sun is rising from east to west. That's because we're turning into the sun. So again, that's the apparent path of the sun. It's not the real path of the sun. The sun is not rising and setting. The Earth is spinning, and that's what creates that illusion. So I wanted to show you that, and compared to the previous slide, the Earth is spinning on its axis point, but it is not spinning straight up and down. There is a tilt to the Earth. That tilt that we see is the difference between the Earth's equator and the ecliptic. If we were straight up and down, we would see that the ecliptic and the equator would be equal. There'd be no difference between the two, and I have a slide to illustrate that. The Earth, over thousands of years, tilts as it spins. So it tilts from one side to the other. This tilt is like a gyroscope. And that tilts one way, and then it tilts back the other way. So this is a natural occurrence And it takes approximately 26,000 years for the Earth to make one complete motion back and forth. So you can see, as we're spinning on our axis, we're not spinning straight in space like that previous illustration. We're actually spinning, and we're tilting as we spin. So the Earth is still spinning on its axis, but it's moving back and forth kind of like a top. And as it spins, the celestial equator stays steady with the equator of the Earth. The celestial equator is always lined up with the equator of the Earth. So when we move back again, like to this other side, we see that the celestial equator, this line, red line that runs around here, is still lined up with the equator of the Earth. It's important to keep in mind the celestial equator stays in alignment with the Earth's equator. That's moving. That's not fixed. That moves back and forth. It's called the precession of the equinox. So that is the movement of the Earth. Whereas the zodiac itself, which is on the ecliptic, stays fixed in space. Remember that point. The equator, celestial equator, moves back and forth with the motion of the Earth, but the stars, the constellations, and the zodiac stay fixed in space. That's a very important point.